This is our last practice problem for the 1 mean Z test. This is called calcium and rainwater. Calcium is essential to tree growth because it promotes the formation of wood and maintains cell walls. In 1990, the mean concentration of calcium in precipitation in this area in New York was 0.11 milligrams per liter. A random sample of 10 precipitation dates in 2007 was taken, and that data is available to you on the tab called Rainwater Calcium. Does the sample evidence suggest that the mean calcium concentrations have changed since 1990? Assume that the concentrations are normally distributed with population standard deviation 0.08 milligrams per liter and use the 0.05 level of significance. So go ahead and pause the video and give this one a try. All right, let's take a look at this together and see how it went. So the P is the parameter statement, what they're asking us to do. So we're going to test the claim that the mean calcium concentrate is not 0.11. H is for our hypotheses. So our null hypothesis is mu is equal to 0.11. And our alternative is that mu is not equal to 0.11. Our assumptions and conditions. So it does say that we have a random sample, but our sample size is 10. So large isn't going to work here. But it does tell us that we can assume the concentrations are normally distributed. So normal is fair game, and that's stated here. And then our population standard deviation sigma is given to us as 0.08. So because my standard deviation comes from my population, that's what gives me a 1 mean Z as in zebra test. My test statistics, so to do the test statistic, you do need the sample mean. So you're going to have to go to the data set and then get the average for those calcium measurements. So the average came out to 0.157. So my test statistic is 0.157 minus that null hypothesis, 0.11. The whole thing is divided by 0.08 over the square root of 10. So this gives me 1.86 as my test statistic. And then this is a two-tailed test. So I do need to make sure I grab the correct probability here. And I got P is equal to 0.063. So that is 6.3%. That's definitely bigger than the 5% alpha they gave us in the problem. So I do not reject the null here. So my conclusion statement is, with a p-value of 0.063 at the 5% significance level, we do not, so that matches your decision in M, we do not have sufficient evidence the mean calcium concentration is anything other than 0.11. You could have also said we don't have sufficient evidence the mean calcium concentration differs from 0.11 or is not. So there's a lot of different ways you can say that. As long as you get an equivalent meaning there, you are all good.